Hi everybody, welcome back. Today is an exciting day because we are finally finished with our geometry unit and we are starting with the very last unit of the year. So congratulations on making this far. So the very last unit of the year is here. If you go ahead and take a look at my screen, Unit 7. And the title of the unit is Quadratic Functions. Quadratic Functions. So go ahead and update your table of contents. I know that I'm not actually physically checking your notebooks anymore, but I would still recommend that you guys keep up with the table of contents to keep your notes organized. And if it's organized, it'll be easier for you guys to use it next year if you need to review or look at, what we did before and whatnot. So try to, keep up with the table of contents. So why don't we go ahead and begin? So the very first notes for today is called quadratic functions. So go ahead and title your notes quadratic functions. And let's begin by talking about what quadratic functions mean. Up until now, we've talked about two different functions. We've started with linear functions. We've looked at exponential functions. And then now we're looking at the very last one of the year, which is quadratic functions. So what exactly is a quadratic function, right? Let's take a look here. It says a quadratic function has a variable with the greatest degree of 2. So what that means is a quadratic function has a variable, usually variable x, and the greatest degree of 2 means that it has an exponent of 2. And the standard form of a quadratic function is y is equal to ax squared plus bx plus c. So what this means is, you know how in linear functions we've called that y is equal to mx plus b. And now whenever I say y is equal to mx plus b, you guys think of linear functions. Same thing with the quadratic function. Quadratic function is y is equal to ax squared plus bx plus c. Finally, the graph of a quadratic function. Graph of a quadratic function is called a parabola. The word again is parabola. And what a parabola is a U-shaped graph, like the letter U, U-shape. So if you go and take a look at down here, you see that we have a sketch of a parabola down here. So that should have an arrow. So this is what an example of a quadratic function looks like, a U-shape. It could be a U-shape like that, or it could be upside down, like so, okay? So just like this, like an actual U or an upside down U. So why don't we go ahead and begin? We're gonna go ahead and go over some vocabularies that are related to quadratic functions. First one is this, vertex. The word vertex means the maximum or the minimum of the parabola. In other words, what is the highest point or the lowest point of the graph? So let's take a look at the graph that's given to us here. So ask yourselves, do we have a highest point? So what these arrows on the ends are telling us is that the graph is going up forever and ever and ever, right? So if it's going up forever, do we have a highest point? No. Then do we have a lowest point of the graph? Yes. The lowest point is down here, right here. And that point, oops, sorry. Let me make it neater. This point right here is the lowest point of the graph. So this is called the vertex. The vertex of the parabola. And this point is at 0, 2, right? Your x is at 0, y is at 2. So our vertex is 0, 2. So I'm going to go ahead and write that over here. Next, we have domain. I don't know if you guys remember domain and range, but remember domain means all the x values that are covered by your graph. So if you go ahead and take a look here, we see that this graph is going to the right side forever and to the left side forever. So then when your graph is doing that, we call that domain is all real numbers. All real numbers. Or it's also called negative infinity, is less than or equal to x is less than or equal to positive infinity. So hopefully you guys remember domain and range. Okay, next word is range. So same thing as domain, except which y values, right? Which y values are covered by your graph. So we can see here that it starts at 2, our y value starts at 2, and then our graph goes up forever and ever. So then we say, oops, that is y is less, nope, the other way. Y is greater than or equal to 2, right? Because our y values are bigger than 2. So the lowest point is at 2, and all the other values are greater than 2. So y is greater than or equal to 2. All right, final word is axes of symmetry. The word axis of symmetry means where can you fold a graph in half so that your graph can overlap each other perfectly. So kind of like the middle point, right? So that imagine folding this U in half so that the sides are exactly symmetrical to each other. So they fold right on top of each other. And in this case, that point would be right here. Along this line, if you folded your graph in half, our left side and our right side would be overlapping each other perfectly. Remember we talked about writing equations for lines that go straight up and like this, or go across horizontally like this. But for vertical lines that go up and down, that is x is equal to whatever the value is, right? And in this case, our x value is at 0. So our axis of symmetry is x is equal to 0. And now we're finished. So basically these 4 things are what we are learning today. So let's take a look at an example. The example here says graph the following quadratic function and answer the following questions. The equation is f of x is equal to negative 3x squared plus 6x plus 3. So first thing you have to do is graph the quadratic function. To graph, we are actually going to use Desmos. So then you would go to desmos.com, click Start Graphing, and then once your graphing calculator pops up, go ahead and type in the equation. So f of x is equal to negative 3x squared plus 6x plus 3. And there we go, we have our graph. So let's go ahead and answer the following questions. First one is vertex. Remember, vertex is the highest, the maximum, or the minimum of the parabola, the highest or the lowest point. In this case, because your graph goes down forever, we don't have a lowest point, but we do have the highest point. The highest point is right here, and this is at 1, 6. So our vertex is 1, 6. And then domain. Domain is your x values that your graph covers. This graph goes to the left forever and to the right forever. So here we call that all real numbers. Same thing as the example that we saw before. And then next we have range. Range is the y values that your graph covers. Here in this case, the highest point is at 6, and then our graph goes down forever. So again, the highest point is at y is equal to 6, and then our graph goes down forever. So then we say our y values are less than or equal to positive 6. And then finally, axis of symmetry, right? That's the line where you could fold your graph in half, and then your graphs would overlap each other perfectly. So then in this case, it would be this line right here. And if we had drawn a line down this way, that would be, again, if it's a vertical line, right, up and down, that is always x is equal to what, right? What value is it? So in this case, it would come down here, and over here would be 1, positive 1. So our axis of symmetry is x is equal to positive 1. And then that's it. So that is it for today's notes. Make sure you have everything copied down, including the graphs here. For today's work, you can go ahead and use the Desmos calculator, the graphing calculator like so. Don't forget the calculator is the graphing calculator, not the scientific calculator. And then you should be good to go. If you have any questions regarding what I covered today, please send me a message on Schoology. And then, yeah, that's it. All right, hope you guys are doing well. I miss everyone. Goodbye.